All right, let's take a look at the last example of using our summation formula for an arithmetic series. Hopefully you've tried this one on your own, and then you're going to check your answer here and see how you did. If you haven't tried it yet, go ahead and hit pause on the recording, try it, and then let's see if you got the same answer as me. All right, so we're finding the sum of the series using the formula. Now, number one right here, we know our formula is n times a sub 1 plus a sub n divided by 2. So looking at this formula, we have to decide what all these values are. So n is how many terms you're summing. So if I'm going from 1 to 30, that is going to tell us that I am summing a total of 30 terms. I then have to find a sub 1. So remember, a sub 1 is me just using this formula and plugging 1 in. So I'm taking negative 8 times 1 plus 40, which is going to give me 32. All right, and then I need to find my a sub n. So how do I know what value to use here? Well, remember, I'm summing 30 terms, so that's my last term that I'm summing, so that's going to be 30. So it's basically your first term and your last term that you're adding together. So now we're going to do negative 8 times 30 plus 40, and that's going to give me negative 200. So now it's easy breezy, plug everything into your formula. We're summing a total of 30 terms. So I have 30 times my first term, which is 32, minus my last term. Normally it would be a plus, but since it's a negative 200, I can just do minus, and then all divided by 2. And the summation of those first 30 terms is going to give me negative 2,520. All right, hopefully you got that one. Okay, the next thing, oh, sorry, one other thing I wanted to mention is, once again, this is convergent. Okay, this is convergent because I could actually find the sum. It converges to an actual number, which is negative 2,520. If this was to infinity up here, then that would be divergent because I can't add an infinite number of terms. All right, so the next thing that we're going to take a look at is we are going to take a look at geometric series and how we can also find the summation of a geometric series. So let's take a look at this geometric series or sequence. In order to make this into a geometric series, remember what we're going to do is we're literally just going to add a plus sign between them. Okay, now remember this dot, dot, dot here, that means it's basically we're going to keep doing that until infinity. Okay, so that's going on forever and ever. The next thing that we want to do is we want to find the summation notation for the first 4 terms. All right, so remember your summation notation is your sigma. N equals 1, I'm starting at 1. Where am I ending at 4? So that 1 at the bottom is your starting. The 4 at the top is your ending. So remember your geometric formula is your first term, which in this case is 7, times your ratio. What are we doing? Every single time we're multiplying by 4. So 4 to the n minus 1. Okay, so now what we're going to do is find the sum of the first 4 terms using our formula for a finite geometric series, okay? So the sum of the first n terms with a geometric series with a common ratio not equal to 1, okay, so that's just telling that our ratio is bigger than 1 or smaller than 1, is n. Remember, that's how many terms you're adding. It's going to be your first term. This is the one that's a little bit ugly. So it's 1 minus your ratio all raised to the n. That's the number of terms that you're adding, all divided by 1 minus r. So the tricky part here is on your graphing calculator, just making sure you do the order of operations correctly. So I would make sure that you do this. Make sure you're plugging that into your calculator correctly. So if I would do 1 minus your ratio all raised to your n value, then multiply it by your a sub 1, then divide it by 1 minus r. So just make sure you're doing that correctly. If you have a negative, just make sure that you're plugging it in as like, maybe that's a negative 2 raised to the 5. So make sure you're putting parentheses around that, or it's not going to give you the correct portion for that numerator. So just be careful with that. Now, this is a finite geometric series. So since this is a finite geometric series, this is going to be a convergent series. So remember, convergent means I can find the sum. It converges into one number. All right, so if I can find the sum, it is convergent because I can actually get that answer. And finite means I'm ending at some specific point here. I'm not going on forever and ever. So in this case, this is a convergent series. All right, so given the series, let's just practice using that formula. We're going to find the following information. So actually, if you would go ahead and try these using that information that I just gave you, go ahead and try them and see how you do. Hit pause, and then when you're ready to see the answer, go ahead and hit play. All right, so let's go ahead and find the rule here. So notice, I know this is geometric, so how am I going from 1 to -4 to +16? Remember, every time since we are alternating between minus plus, that is going to tell us that we are going to be multiplying by a negative. So we're doing 1 times -4 times -4 times -4. All right, so we know that our ratio in this case is -4. So let's write our rule. Our first term, which is 1, my ratio, which is -4 to the n minus 1. So now what's the summation notation for the first 10 terms? So I'm only going to add the first 10 terms. So n equals 1 means I'm going from the first one. 10 at the top means I'm adding up to 10 terms. So the first position, second position, third, fourth, fifth, sixth, 7, 8, 9, 10. Okay, of -4 to the n minus 1. Now you might ask me, what happened to that 1 that was out here? Well, you don't have to write that. You could write the 1 there, that's totally fine, but you don't have to. All right, so how can I sum the first 10 terms? So what that looks like in our formula, I'm summing the first 10 terms, so I'm going to put the 10 there to show that I'm summing the first 10 terms. The first part is your, let me actually just write the formula here for you in case we forget. Okay, what is our first term? Well, our first term in our series is going to be 1. Okay, so I'm doing 1. All right, and then I'm doing times. Okay, 1 minus r to the n, 1 minus, my ratio was -4. Make sure you put that in parentheses. N is how many terms we're adding, so to the 10th, all divided by 1 minus -4. Okay, so if we're going to simplify this, the bottom's not too bad because I'm just going to have a 5 there. So what I would do is make sure on your graphing calculator that you're plugging this in to look like this so that you don't mess something up, okay? So you're going to do 1 minus, make sure you put that -4 in parentheses, okay, all raised to the 10th power, then hit enter. Okay, notice I got my answer. I could multiply it by the number out front. In this case, it's just 1, and then you're just going to divide that by 5, and that gives you your answer of -209,715. I'm not going to write that part of the answer there. So just make sure that you can get that on your graphing calculator. Okay, now letter D is going to be a little bit trickier. Actually, let's answer E before we answer letter E. So in this case, is this convergent or divergent? So in this case, our answer is actually convergent. Okay, why is it convergent? It is convergent because I can actually find the sum. I found the sum of the series. That sum was -209,715. Okay, so letter D says we're actually finding, our goal is how many numbers do I have to add together to get 800 and -819. So let's take a look at our formula here and see what we can plug in. Well, S sub n we know is -819. Okay, A sub n we also know is going to be 1. Okay, what is my ratio in this case? My ratio was -4. We don't know the n, so we're going to leave that there, all divided by 1 minus -4. Now let's simplify this to the best that we can. All right, so first of all, we know we have -819. I'm going to take that 1 out the front because it's not doing anything, okay? All divided by 5. So we're going to try, our goal is to get that n all by itself. Let's move everything around on the outside of it. So what we're going to do is multiply both sides by 5 to get rid of the fraction in my denominator, okay? And once I multiply both sides by 5, I end up getting negative 4,095. What do I have left in my numerator? 1 minus negative 4 to the nth. So let's try to get this piece all by itself, okay? So what we're going to do is subtract 1, and you get negative 4096 equals minus negative 4 to the nth, okay? And then once we've done that, we want to get this whole thing, everything with my exponent all by itself. We don't want anything outside of the exponent. And then what we're going to do is divide by negative, okay? So that makes everything positive. 4096 equals negative 4 to the n. All right, so what we want to do now is, since I have an exponent, how do I get rid of my variable in the exponent? Well, you just learned about logs. So let's go ahead and take a minute and use logs in order to solve this. All right, there's actually 2 ways that you can do to solve this. You can rewrite this as a log. So when I rewrite this as a log, remember that when I rewrite this as a log, the base of my exponent is the same as the base of my log. Okay, this is the number next to log, 4096, and then what's the exponent is what's after the equal sign. So now you might say to yourself, wait a second, there's a negative here. I can't take the log of a negative. In this case, you are going to ignore the negative. Okay, so you're just going to kind of pretend like that doesn't exist, and you're just going to type it in as log base 4 of 4096 equals n. Okay, and as you type that into your graphing calculator, you're just going to get n is equal to 6. Now, if you have an older graphing calculator, you might have to use the change of base formula. So your calculator doesn't naturally allow you to change the base to 4 from 10. So remember, your change of base formula is just the log of whatever is on top, the 4096, divided by the log of the base, which in this case is 4, and that will also give you 6 for your answer. All right, and go ahead and for your next video, this is your next example. I'd like you to try it, and then the next video we'll go over the answer.